Hi, the SI meteorologist Paul Dorian here. Well, we're approaching the middle part of November, that time of the year again where we like to take a look at the potential winter weather conditions here in the Mid-Atlantic region for the upcoming winter season. I believe there are three major factors that will play an important role in leading the Mid-Atlantic region to a somewhat colder and snowier winter than normal. Number one, currently is a neutral El Nino Southern Oscillation, or ENSO, signal coming right now from the tropical Pacific Ocean, and I believe that neutral signal will continue right through the upcoming winter months. Number two, even though we are approaching the solar maximum period of the current solar cycle number 24, it is one of the weakest solar cycles in many decades, still on pace for perhaps the weakest solar cycle in 100 years or so. Typically low solar activity, which I believe will experience right through the upcoming winter months, leads to frequent high latitude blocking. That could turn out to be the most important factor of all, pushing the Mid-Atlantic region towards the cold and snowy side for the upcoming winter season. Finally, the snowpack in the northern hemisphere, and specifically Eurasia on the other side of the North Pole at the end of the month of October and whatever is going on during the fall months, tends to have an important role in potential cold air outbreaks for the central and eastern U.S. a couple of months later. And indeed, there was quite a substantial above normal snowpack in Eurasia and throughout the northern hemisphere as we finished up the month of October. So again, I think these three major factors right here will lead the Mid-Atlantic region to a somewhat colder and snowier winter than normal, perhaps temperatures averaging some a half a degree to 1 degree below normal during the winter months. These are the normal snowfall amounts in the big cities: 15 inches at Reagan Airport, 21 inches at BWI and Philly International Airport, 29 inches of snow normal at Central Park. I believe this will be the minimal amount in these big cities, and the suburbs several inches higher as well. Anywhere from perhaps 100 to 140% of normal snowfall expected for the upcoming winter season. Well, let's first start off by looking at the tropical Pacific Ocean. These are sea surface temperature anomalies. This is the latitude for the equator right here. This is 0 degrees. We tend to focus in on the west coast of South America in the tropical Pacific Ocean to see what's going on with respect to El Nino or La Nina. El Nino is when temperatures are above normal, La Nina below normal. The above normal sea surface temperatures indicated here by the yellows and oranges, and the below normal by the blue. And as you can see, it's a kind of a mixed bag, a patch of above normal, patches of below normal, a rather neutral signal. I believe that will continue right through the upcoming winter months. Why is this important? Well, if there was a strong signal coming from the tropical Pacific, for example, a strong El Nino, that could just overwhelm any other factor. Whatever's going on in the North Atlantic might not matter. For example, if there was indeed a strong signal coming from the tropical Pacific, a strong El Nino would tend to flood the U.S. with milder than normal air throughout the winter months, no matter what's going on the sun or on the northern Atlantic. This, however, is a neutral signal. It looks like that'll kind of open the door for some other possibilities. And again, I believe high latitude blocking could end up playing a major role in the Mid-Atlantic region upcoming winter season. By the way, this is neutral signal. What would a strong La Nina look like? Well, let's take a look right now. Here is indeed a strong La Nina pattern from the latter part of 2010. All this area, widespread area below normal temperatures off the west coast of South America. At the end of 2009, on the other hand, we had a rather strong El Nino with oranges and yellows here, a widespread area of above normal temperatures. So I think we're in general agreement here that we do not have a strong signal coming right now. It's certainly not strong El Nino nor a strong La Nina, but rather a kind of a hodgepodge here of above and below normal temperature, a neutral signal from the tropical Pacific Ocean. Well, certainly one of the reasons I believe the neutral signal coming from the tropical Pacific will continue is just a summary chart right here from Columbia University that shows a whole bunch of dynamical and statistical models with respect to sea surface temperature anomalies in the tropical Pacific. This is a neutral line right here, the 0.0 line. Anything above in this region right here is considered to be El Nino, warmer than normal temperatures. Anything below is La Nina, colder than normal temperatures. You really have to go maybe a 1.5 and above to get a strong El Nino, or negative 1.5 and below to get a strong La Nina. Basically, it looks like we remain neutral right through the upcoming winter months. This is the December, January, February time frame right in here. A few of the models are slightly above, a few are slightly below, but generally it looks like neutral conditions will continue in the tropical Pacific right through the upcoming winter season. Well, because we have a neutral signal coming from the tropical Pacific, that opens the door for some other factors to play a crucial role. For example, what goes on in the North Atlantic, which has a direct impact on high latitude blocking. And there certainly have been some studies that correlate low solar activity with high latitude blocking. By high latitude blocking, I mean strong high pressure in the mid and upper parts of the atmosphere over places like Greenland that tend to force Arctic air to come down from central Canada into the central and eastern part of the U.S. can play a crucial role in the mid-Atlantic, northeastern U.S. winter weather pattern here. Now, this is the monthly sunspot numbers going back several solar cycles. And again, we are in a weak solar cycle right now, right in this region, right in here. Solar cycle number 24, one of the weakest solar cycles going back decades and decades. Perhaps it'll end up being one of the weakest solar cycles in about 100 years or so. And notice here, one of the things I'm going to show next is the correlation between low solar activity and high latitude blocking. Some of these time periods right in here, the middle 1950s, for example, low solar activity, the kind of the middle part of the 1960s, low solar activity. Same thing, the middle latter part of the 1970s, kind of the latter part of the 1980s. These will be analog years that I use in the upcoming chart. I'll show that indeed show a signal correlating low solar activity with strong blocking at the high latitudes during the winter season. So again, I'm certainly expecting the low solar activity from this weak solar cycle to continue during the upcoming winter months. Well, what we have here is quite a strong signal showing up here. This is using analog years, which I just talked about a moment ago with respect to low solar activity in the middle part of the 1950s, the middle part of the 1960s, the middle latter part of the 70s, middle latter part of the 1980s. Low solar activity periods, which I believe we are in right now, leads to this 500 millibar geopotential height anomaly chart that shows a very strong signal here of high latitude blocking. This is Greenland right here, and what we're seeing is a very strong signal during low solar activity years. And again, I believe that will play a major role in this upcoming winter season, where we have strong high pressure at the mid and upper part of the atmosphere in the high latitude areas such as Greenland. That tends to force cold air outbreaks, Arctic outbreaks down from central Canada into the central and eastern U.S. Notice below normal heights here in the central and eastern U.S. during these winter months. This is for December through February time frame for these low solar activity analog years. And again, I think this is a strong signal. It is something that we can track through the North Atlantic Oscillation Index. The NAO index typically runs negative when there is a high latitude blocking situation. This is important because not only does it allow for Arctic air outbreaks to drop down into the central and eastern U.S., but a long-lasting negative NAO tends to favor sustained cold air outbreaks as well. Obviously, cold air is necessary for snow, and I believe this is a major factor in the upcoming winter that will lead to colder than normal and somewhat snowier than normal conditions in the Mid-Atlantic region. Well, in terms of snowpack across the northern hemisphere, and specifically in the Eurasia region on the other side of the pole, this is from the Rutgers Global Snow Lab for the end of October. It's a departure from normal. All these areas in blue represent above normal snowpack, and you see right across the North Pole in Siberia, for example, in the Eurasia area, above normal, even a large patch in central China with above normal snowpack. So there have been studies that show increasing snow in Eurasia during the month of October to above normal snowpack by the end of the month, the early part of November, often correlates to cold air outbreaks in the mid-Atlantic region, the central and eastern U.S., a couple of months later in the heart of the winter season. So I believe this will also play a role in leading towards a somewhat colder and snowier winter here in the mid-Atlantic region. A little bit more on the snowpack. Exactly how much above normal was the snowpack at the end of October in the Northern Hemisphere? This too is from the Rutgers Global Snow Lab for the month of October. Notice here the ranking. It was the 7th highest snowpack in the Northern Hemisphere in the last 46 years. So quite impressive indeed. Now, how about Eurasia specifically? How did that rank in terms of the last 46 years? Indeed, it was one of the highest, the 4th highest snowpack in the last 46 years in Eurasia. This data, again, coming from the Rutgers Global Snow Lab. Notice here, by the way, this maximum year, the October of 1976. Boy, this led to an incredibly cold winter season of 1976-77. So the snowpack in Eurasia is an important factor. I believe these 3 factors, the neutral signal from the tropical Pacific, the low solar activity, which leads to high latitude blocking, and the above normal snowpack throughout the northern hemisphere at the end of the month of October, will lead us to a somewhat colder and snowier winter here in the mid-Atlantic region. Obviously, we'll follow this and monitor this over the next several weeks here at the SIweather.com. That's it for now. For the SI, I'm meteorologist Paul Dorian.